Yes, certainly. So my name is Alistair Basden, and I am a HPC technical manager at Durham University, where I manage a DiRAC HPC system there. So DiRAC is a Tier 1 UK national supercomputing facility, primarily for the astronomy, cosmology and particle physics communities, and it's funded by one of the UK research councils. It provides HPC access based on facilities at 4 sites: Cambridge, Edinburgh, Leicester and Durham. And at Durham we host the memory intensive service, so this is specifically for simulations that require large amounts of memory, large amounts of RAM. So the system that we have at Durham is a medium-sized HPC cluster. We have about 450 compute nodes, each with 28 cores. But the main thing about this cluster, which makes it unique, is its large amounts of RAM. So we have about 230 terabytes of RAM spread across the cluster. We also have approximately 10 petabytes of storage, which we use to store simulation data. And when users have generated that, it gets stored to disk. So we have 4 generations of file system, which include GPFS file systems and more recently Lustre file systems. We also have user home space, which is on a shared XFS file system mounted over NFS. So we were looking for several things. One was the ability to back up, to archive in a file format that is open. So for that we chose the LTFS linear tape file system, which means that in 10 years time, 20 years time, that data is still accessible. There's no proprietary format. It's also important for us to be able to manage this data well, to have a database that tells us what files are archived, where they are, which tapes they're on, and different versions of files that have been archived, and to be able to restore those appropriate to the version that a user requests. It was also important to us to be able to do incremental and full backups. So at the moment, important for us is long-term storage and retention. The UK research councils try to guarantee to store data for at least 5 years, and many of our users want to store the data for much longer. If they write publications, they will want to revisit those in 5, 10, 15 years time and expect the data to be still available. And we want to make sure that data is there, uncorrupted and easily accessible for them to use. One of the benefits we found from Atempo is the ease by which we can move data around our system. So we can transfer data from file system to file system, and more importantly, transfer it to tape for long-term storage. This is something that's easy for us to administer. It has a very low barrier for entry. It's also something that our users will be able to use to manage their own file systems, their own data, to free up this amount of storage they have on spinning disk and dictate what they put to tape. On a daily basis, they have the security now of knowing that their data is backed up. It's very important. We have significant redundancy across the system, but prior to this, in case of complete failure, we would not have been able to restore data. So now we have a backup of home space. We are also able to archive to tape important projects, important data that's been generated, milestone projects if you like, and the ability to do this means that we can restore that data rapidly wherever we need it.